Hello guys, you're welcome to God Academy. In this lesson, I'll take you through the principle of well ordering. In our previous lesson, we looked at order relations, the transitive, the symmetric, and the other properties. Do well to go back to our videos and also stay glued to your seat, watch this video to the end. Don't forget to subscribe. The principle of well ordering is simple property which is mostly used in natural numbers. So in natural numbers. In an attempt, in an attempt to order numbers, we use order relations. But the principle of well ordering strictly says that every non-empty, okay, every non-empty set, or let me say subset of n, which is natural numbers, has a least number. Mathematically, I can say that S, which is a subset of N, right? And where S is not an empty set, then there exists a number M, which is also a member of the set S, such that M is less than or equal to S, okay, for all S which are members of S. Beautifully. So a principle of well ordering is saying that for every non-empty subset of n, it has a least number. If I take, natural numbers as covered in our previous lesson, it starts from 1 and goes to infinity. If I take any subset, so let's say I say 3, 4, 5, 6, this is a typical subset of natural numbers. In this set, I have a least number, a number set that is the smallest number in this set, that is 3. Hence, I'll say that these numbers are what? Well ordered. So natural numbers are well ordered so that any subset or any small group you set, you should have a least number. That is the whole idea of well ordering. Okay, so mathematical relation here is saying that we have a subset, a bigger S, which is a member of or a subset of what? Natural numbers, provided that my new subset is not empty and I have elements, then surely there is this particular element within my new subset called M that will be the smallest number, and that is the idea of well ordering. So we say that N is well ordered with this. Mostly you see this, okay? Looking at integers, integers with a Z, you realize that integers, you have 3 dots, -3, -2, -1, 0, 1, 2, 3, to infinity. What this is trying to say here is that integers doesn't have a least number on the left, on the right side. It goes to infinity. So integers are said to be not well ordered. So the appreciation of well ordering is that there should be a least number, and all the time that least number is what characterizes that particular group of numbers as well ordered. See you in the subsequent videos as we delve deeper into mathematical induction, see the different types of mathematical induction with proofs. Until then, bye.